You have a lot of freedom. You get to do exciting work. Nobody tells you ये research करना है, वो research करना है, जो आपको interest है वो करना है.
So Professor Harish, thanks a lot for this opportunity you gave me to sit here and interact with you in IIT Gandhinagar. And this lab, you have shown me this lab a couple of moments back, and now I am interacting with you. Thanks for this opportunity.
Thank you. It's my pleasure.
Okay. So Professor Harish, I want to know through you what are your research areas, research domain areas in which you are working presently.
Sure. So we have a fairly wide area of interest. One of the major areas that we are working on is robotics.
Okay.
But there are also a couple of other associated areas. We do work on projects related to control systems or automation. We also have interest in the area of dynamical systems. And also there is some interface with cognitive science and neuroscience where we are sometimes learning from ideas in cognitive science, how humans do things and can we learn and use that in robotics. So these are the general areas, and in research we have interest right from understanding the fundamental concept of how to control this or how to do force control in robots, or how compliance is used for manipulating objects, all the way to actually building a hardware, looking at how the performances in experiments, sometimes developing a hardware solution, sometimes developing a product. So we have that way very wide.
Okay. So I can see a lot of projects in your lab. You have developed quite good test rigs and devices also here. So Professor, what are the different research projects you have handled recently and you are handling presently?
It's a long list. So we are very curiosity driven. So we see an interesting problem that nobody has solved and we try to explore and see if we can solve that. But there are 5-6 projects that are currently going on that are exciting projects that I could just briefly mention.
Yes.
One of the projects is the gate trainer that you can see in the background.
Okay.
This is a robotic exoskeleton, but a much more inexpensive way to do things rather than the more expensive exoskeletons that are out there. Those are not very well suited for Indian conditions because they are extremely expensive and the general public will not have access to them. The idea we are exploring here in collaboration with the University of Texas at Austin is how to use intelligent mechanical design to make it much cheaper and much more accessible, but without compromising on accuracy. So this is one kind of project where robotics we certainly need, but we also need to understand a little bit about the medical side, the rehabilitation side, the cognitive science side. But we also have interest, we have 2 or 3 projects which are studying different aspects of how we can use flexibility or compliance, or in very simple terms I would say soft touch in robotics, and again that has very wide applications. One is at very small level. Imagine a robotic finger grasping something and then manipulating it in various ways. The dexterity or the range of things that you could do with such fingers. You can exploit compliance in the robot to do something that traditional rigid robots will not be able to do. And humans are very good with that. So we want to learn from humans and try to see if robots can have built in those kind of features. So there are 2 or 3 projects studying various aspects of that. We have also projects which are studying more basic but interesting dynamics and controls problems where there are 2 or 3 different degrees of freedom. They are interacting with each other, they are coupled with each other, but it's very hard to control, and the dynamics is very hard to understand and predict. So there are projects along those lines where there is much more math involved because we are going from scratch, figuring out the dynamics, then the controls, then the implementation. There are also recently we started working on an ISRO funded project to develop an actuator that will be used in humanoid robots, hopefully if we are successful. So that's an exciting project for us where something that we do in the lab might actually directly be used in real world out there. It might go to outer space apart from that, there are also a number of other projects. You heard Aishwarya earlier in the interaction, where we try to learn how humans are controlling their own posture, and there are some interesting concepts there that we think are useful in other domains such as robotics, where humans are actually not trying to control their posture all the time. They control it intermittently. So what I mean by that is, the control is not on all the time. So you are not correcting yourself all the time. You are only correcting yourself intermittently. But in robots, if you see, all the control systems are always on. So we want to see how we can bring in intermittent control, learn from what humans are doing, and again bring it to different domains. And that's another exciting project. So likewise, there are a number of projects.
So Professor Harish, I was interacting with the students in your lab. So I found they are from different diverse domains, from mechanical engineering, electrical engineering, instrumentation, and then biomedical. So I want to ask you, like, is there any other domain which we are looking for, or there is an opportunity for some another domain of expertise, students from other domains who can also join the lab which you have and all? So what kind of students can aspire to be in robotics?
No, absolutely. I think there are, when electrical engineering students can do well in robotics, computer science, now there is a lot of emphasis on learning algorithms and AI in robotics. I think computer vision is now a very big part of robotics, where camera looks at something and you want to recognize, the robot should recognize its environment, perceive its environment. There are a lot of interesting problems there, so I think that's another big area. But even otherwise, I think robotics is a fairly wide area. I think there's opportunity for. So currently I'm teaching an introduction to robotics class. I have even civil engineers in my class, because they later on want to work on, in fact, a recent startup has already built it here in IIT Gandhinagar, but this idea of 3D printing concrete.
That's going on.
That's going on. But now that is again robotics. You need to know some robotics to be able to do that. So you will see robotics is useful everywhere.
So nowadays, I read in literature sometimes that artificial intelligence in robotics is something which is coming up fast. So what is that new area of use of artificial intelligence into robotics?
So artificial intelligence is a very wide term. I am not the right person to be commenting on that, so I will not comment on that much. But I would certainly say that the element of learning has really penetrated a lot of engineering fields, including robotics. Where earlier we were thinking of robots as we need to figure out all the different situations a robot can potentially be in, and we need to program the response ahead of time. So we need to plan everything ahead of time. If you need to do this, this is what could be done. If you need to do that, and those are the only things robot will do. But now we are thinking of bringing in learning, and that's a lot of labs, and we ourselves also explore that with great interest. Where initially when we are programming the robot, we don't know everything that it will do, but the robot will gradually learn as it is interacting, as it is repeating certain tasks. So learning is certainly there everywhere. Even as something as simple as some diagnosis using sensors. Even some static situation where there is some piping network, you have pressure sensor. There is no robotics, there is no movement. But learning from past data and figuring out where there may be a maintenance issue, where to fix. I think those learning has become pervasive now, and I think that is very important.
That's true. Professor, I was interacting with the students in your lab. There are students from BTech, there are from MTech, there are PhD, postdoctorates, and JRF research fellowship. And you mentioned that there is opportunity for internship also. So I want to ask you, like, there are so many colleges in India where students are not that lucky to have this kind of infrastructure in their colleges, and they aspire to have a short-term courses or summer internship in some center of excellence like yours. So do you have provision, something like that?
Yeah, absolutely. There are a lot of different opportunities. We have what we call summer research internship program, SRIP. Where people from all over the country can apply.
Okay.
But we also have many other opportunities which are smaller. You know, somebody wants to spend an entire semester here, entire year here.
Okay.
That is possible. So we have a non-degree program where even if somebody is not our student,
Okay.
they can actually do our courses.
Okay.
They can spend a year here, and they just need to take permission from their own their own college.
Okay.
And of course they will have to pay fees here.
Okay.
You know, whatever the regular fees is. But it is open. Anybody can
It is
come.
sort of certification course. At the end of the course, you will.
They don't get any degree.
Okay.
But they will get a transcript. They will get grades for the
Okay.
courses they have.
That
So they've taken 5 courses here.
Okay.
They've taken robotics, artificial. They will get a transcript. Say at IIT Gandhinagar you did these courses and these are the grades that you
Okay.
got. And they can use that in various ways.
And they can stay in the hostels or something.
They can stay in the hostels, and there is an application process for that, but it's you know very accessible. Anybody can do that.
Okay.
But there are smaller opportunities also. If somebody wants to just spend 2 weeks,
Okay.
they can just write to any of the professors.
Okay.
Sometimes professors will be willing to host people in the lab and say, okay, we can come and explore for 2 weeks.
Okay.
Then there are also short workshops that are going on that are offered from time to time.
Okay.
Again, that is open to everybody. So there are many different
Okay, this kind of opportunities.
Yeah, and I would encourage
Yeah.
your viewers to keep
No,
their
there
eyes
is-
and ears open for such
Yeah.
opportunities. There are a lot of such opportunities that you should get.
Yeah, because there are 6 months, altogether 6 months internship in some colleges, they tend to go to industries for learning, and also I believe this is also sort of the same learning.
Yes.
Whatever they are learning there, so the same thing. So is that accompanied by your classes also and theoretical learning also?
I'm sorry. I didn't-
So is that also, the component of 6 months training, other than doing work in the lab, is that also accompanied by the lectures or kind of, theoretical teaching?
So formally it is not, but students can always, informally sign up for 1 or 2 courses, or they can, as I said, the non-degree program, they can even formally sign up. But in a place like ours, where the boundaries are not very firm, some electrical engineering student can go attend a mechanical engineering class, can work in a biomedical engineering lab, cognitive science lab. All of that is possible. Likewise, even for interns, many of those opportunities are there. They can attend many seminars that are going on here. They can attend workshops. They can spend time in the lab. They can talk to other people in other labs. So those kind of wide opportunities are
Okay.
there.
So, Professor, my next question to you is related to the entrepreneurial opportunities related to the field of research in which you are. We understand robotics is a fast-coming domain, and we also know that in India, still we do not have sufficient, these ventures where hardware is being produced. We don't have that. Even now we are importing most of the things. So, what are the various entrepreneurial opportunities for students who will graduate or they do their masters and doctorates in your field of research?
So I think in robotics and hardware, I think there is a huge opportunity.
Okay.
I think the next decade or so, if you think of the last maybe 2 or 3 decades as being the software revolution, where India went from
IT revolution.
IT revolution. Now all over the world, people regard India as good software engineers,
Yes.
and a lot of good software companies in India.
Yes.
I think at that time, we, for whatever reason, were not able to be successful on hardware products. But I think now is the time where I think the next 20 years will be hardware revolution in India. I think next few years, a lot of excellent hardware companies will come out of India, and that's where I think a fresh student can really make a difference. They can start up something on their own. It can really. I think the environment is right, the ecosystem is right. A lot of components are now available in India. A lot of know-how is now available in India. A lot of labs like this where people can go and learn very high-quality engineering. A lot of support for entrepreneurship from the ecosystem, from government, from non-government sources, incubation sectors such as the one that we have here. I think a lot of that is now available. Now I think is the right time.
For this.
If somebody is thinking in that direction, I think this is the right time.
Okay.
Yeah, I will encourage everybody.
Professor, in the hardware-based industries, one of the inherent problem is capital investment. Huge investment is required for that. So can you throw some light on this aspect? What kind of capital investment is required if somebody wants to go into this kind of hardware for robotics or something like that?
I should first say that I don't have that much experience working through the process of establishing a big company. So some of my comments should be taken in that light.
Okay.
But I do think things have changed very drastically in the last few years in terms of even availability of funding.
Yes.
I think even 5 years ago, 10 years ago, if I wanted to build even a fairly small hardware product, I would not know where I would get the money from. I would always have to depend on personal sources of money. I think now the support system that when I mentioned ecosystem earlier, that is also partly what I was referring to. I think there are more ways in which one can support oneself when going through a hardware development process. Yes, there will be substantial investment, sometimes running tens of lakhs, but you are also better able to generate some seed investment in today's ecosystem. Either it's from some incubation center or either it's
some government policy or
government funding, or there are centers of excellence that sometimes fund. There are innovation hubs set up all around the country. There are a lot of small such organizations that one could tap into. Depending on what area you are pursuing, you have to look for what are those areas. But I think that is a very solvable problem in today's world. I think that should not be the impediment.
So that is not the problem. I mean, that solution is there for that.
The solution is there for that. Of course, one has to work hard to figure out where the funding will come from. But it is very much possible.
Okay. Now is the right time. Professor, I come to my last point of interaction, and that is related to actually the students who aspire to be in such labs. So there will be thousands of students who will like to pursue their career in robotics, and they keep on looking for opportunities in institutes like IIT Gandhinagar and to work under professors like you who have done marvelous work in this field. So what do you see in your prospective students whom you will take under your guidance for masters, for PhD programs and all? So what do you see in them? What kind of knowledge should they have before they come? And I could see some of your students into PhD directly after BTech, and then PhD after MTech, and then postdoctorate. What do you see in them?
Okay, this is a fairly complex question, because there is, as you know very well, and as your viewers will know also, there is no simple answer. There is no simple magic pill. But let me try to cover 2-3 different aspects. One, I feel in an area like robotics, and also in many other things people will do in their life, I think knowledge is not what I'm looking for initially. Specific to the problems. So I am not looking for somebody who already knows robotics very well. I think it is going to be a learning process. Anywhere you start a new job, you have to learn from scratch. Right? So some of the people we were talking about, so somebody like Varun, he comes from a very hardcore mechanical engineering training, but now he has to learn electronics, everything in electronics from scratch. And likewise for many other people who are here. So I think that is inevitable. What I'm looking for is somebody who has mastered at least certain fundamental concepts well. It may not directly be robotics. It may be electrical engineering
concepts,
or it could be electronics concepts, but they will learn the other things when they come here, or they will have learned mechanical concepts, but they will learn the other things. So I expect that once people start working on projects like this, the learning will be extraordinary. They will learn a lot while they are immersed in it. But some reflection of what they have mastered in whatever they have done here. But more importantly, I think the attitude and work ethic, I think that makes a huge difference.
Yes.
The attitude that, okay, I want to learn, this is something new, this is interesting, let me try it.
Yes, yes,
Even if I make mistakes, I will learn from it.
Yes, yes.
Then work ethic, where because any real world work, especially challenging work like this, research or entrepreneurship or product development, there will be huge challenges. You will have lots of failures. You will see many more failures than successes.
Yes, yes.
So work ethic is important, that you keep trying. Okay, I failed this time, let me see how I can do it better this time, let me not give up. Next day come and you try again. I think those are some of the things which are much more important than you get. And I think that makes a huge difference over somebody's career, where it's no longer the case that you learn something and then you will use that for 40-year career. That is not the case.
That's not the case.
Every day is your learning experience.
That's right. So to put in your words, a student who does not have a background of robotics but wants to pursue a career in robotics should have a fairly good basics of engineering, and then he should have passion to work in this domain, and he should come with a mindset that if I go to this lab, I need to put effort, I need to learn, so I need to go with the attitude of learning, and I need to put effort.
Yeah, and I think that is true for not just robotics,
anything. That's true.
Anything new you want to do, anything challenging you want to do, anything you want to do on your own, you have to have the time.
Yeah, because I asked this question to many other professors of different domain, and answer is same. Answer is that we don't look for knowledge. Knowledge, so they will get it. We look for something else. And also, as you rightly said, it is a little difficult to tell because there are many aspects to this particular question. So very nicely you have explained, Professor, and I'm really thankful for your very precious time and the kind of information and knowledge you have given. This is a fast upcoming domain, robotics, and I'm very sure students from this entire interaction will get benefited, and those who are dreaming to get into this domain, they will get benefited from this. Thanks a lot, Professor.
Sure, thanks a lot. It's been my pleasure, and I encourage anybody to write to us, just at sysidea@iitgn.ac.in if they are interested, if they have questions in this domain.
Yes.
We can see whatever we are able to answer.
Thanks a lot. Thanks a lot. Okay. So Professor Harish, thanks a lot for first giving me opportunity to visit your lab in IIT Gandhinagar. This is a prestigious lab.
Thank you.
And I'll request you to please tell us various research facilities created in this particular lab in mechanical engineering, and what are the different research projects going on in this particular lab, and what research areas, and I can see many PhD students sitting there, so what areas these people are working.
Sure.
Over to you, Professor.
So first of all, it's a pleasure. Thank you for covering me on your channel.
Yeah.
So the lab that you see over here is the SysIdea Robotics Lab.
Okay.
So we have fairly wide interest in the field of robotics, some control systems, which is essentially automation, and also some dynamics.
Okay.
So these are the broad areas that we cover on.
Fine.
Now, the field of robotics is a fast-growing field.
Yes.
There is a lot of work going on for
Yeah.
past several decades,
Right.
and robots are everywhere. Your viewers are well aware of robots. But
Professor,
one of the
robotics
areas
is also interdisciplinary domain.
Yes.
So do we have engineering graduates from different domains, or?
Yes, absolutely. In fact, we have a fairly wide, people with wide set of different expertise in the lab, coming from various backgrounds.
Okay.
So what I was going to say is, in the field of robotics, the first few decades there was a lot of emphasis on precise motion of robots.
Okay.
And if you go to any industrial setup, any manufacturing facility, you will see a lot of robots. But the focus there is precise movement. So you pick a part from one particular location and precisely place it in some other location.
Okay.
Which means that if there is any obstruction, if a human comes in between, the robot doesn't care about it. The robot wants to still finish its movement. So it's not safe to operate with humans around. That's why you see that they are usually cordoned off, or there are cages where you say this is a safety boundary, you don't enter this area when the robot is operating. So one of the areas that we are very interested in, which is one of the frontiers of robotics, is where you can bring in a bit softer touch in robotics. Right? So when robots are interacting with humans in unstructured environment where you don't know what is around the robot, you don't want to damage the environment, you want to be soft, you want to know when to apply a lot of force, when to apply a little bit of force, when to be gentle, when not to be gentle. Right? So this is one of the emerging areas where there is a lot of research going on how to bring robots in much more safer working conditions. Now, the technical word for that soft touch that I was mentioning is compliance. The robots are more compliant rather than being more rigid. So in this lab, one of the things that we study is really compliance affecting many different things. So in a robot like this is called Whiskey robot. It is fully designed and developed in the lab. Here, even though it's a very heavy robot, very rigid robot, metal, which can damage the surroundings if it but we try to develop strategies and control algorithms where at the end we are able to very precisely control what force of interaction should be there. So even if we keep a sponge here, it can detect that there is a sponge and it will not depress the sponge beyond a certain predetermined threshold. So you want to really bring very high level of force sensitivity and compliance with the so that is one way where compliance or soft touch can come into robotics. Another area where we are really exploring the same idea but in different contexts is very simple tabletop setups like this. But these are really represent the kind of things that happen when humans manipulate an object. So humans, for instance, if I take a pen, humans are very dexterous in doing something like this. Robots are very good at picking and placing, but the dexterity level where you can do something like this, robots are still not.
Maneuverability is your
maneuverability and manipulating an object in various orientation, holding it in various ways and still not losing them, doing interesting things. Now, one important aspect of humans being able to do this is really controlling the compliance, again having that soft touch. So these are setups where we are adding that kind of compliance with the help of springs and helping study the same concepts of how humans are able to do things dexterously. Right? So these are of course simplified setups, but generating fundamental insights that will be useful in wide range of applications in robots. So these are two different setups, studying two different aspects, but the underlying concepts are the same. How compliance can affect performance and dexterity. So this is another area. The couple of other interests that we have. So here we have a robot which we call GATE Trainer. This is actually in collaboration with the University of Texas at Austin. The idea here is exoskeletons are another area where robots interact with humans, and exoskeletons currently are extremely expensive. There are a lot of hospitals in the West that have exoskeletons for rehabilitating persons once they have either a stroke or some kind of injury and they need physical therapy to come back to their original walking performance. Sometimes they are not able to come all the way back to their original performance. But the whole idea here was there are exoskeletons out there, but they are expensive. Can we bring in intelligent mechanical design, but reduce the reliance on expensive electronics and hardware, so that it's much cheaper but can still achieve the same performance and in fact have very high degree of mechanical performance. So what I mean by that is this robot, although it looks complicated, is actually much simple as compared to some of the exoskeletons. And at the moment it is disassembled. There is actually an ankle cuff here. And the whole idea is this will act like if you go to any physical therapy place, the physical therapist will kind of help you take your leg and move that forward. Right? So when you are not able to walk, you will have some kind of support and the physical therapist will help you do this. Here the robot will automate that. So the physical therapist can then focus on the other aspects of learning rather than the physical effort. The physical effort is needed. So this is one other project. another project I could just mention briefly, which is a little different, but again connected to controls, robotics, dynamics. This is again something that is a work in progress, but this is a swirling pendulum, which is a new kind of pendulum, which has 2 degrees of freedom. So the whole idea is there is the pendulum is attached here. There is one swinging that will happen because of this rotation, and then there is other swirling that will happen because of this rotation. Now both of these rotations interact in very interesting ways, creating a lot of different challenges, and this kind of setup helps us study how to control when you have challenges like that, and something like that is very relevant when you're doing spacecraft attitude control or when you're doing robotics control under actuated system. So this is again a setup that is fully designed and developed in the lab. So as you can see in the lab, we have projects that go from very fundamental concepts of how compliance affects certain performance, all the way to developing a hardware, testing it, getting real world insights from experiments, and as you said right at the beginning, this involves a lot of different domains.
Interdisciplinary kind of research.
Very heavily interdisciplinary. So when you look around the lab, you'll see, so we have postdocs like Sujay, who has an instrumentation and electrical engineering background. So Sujay, you can say hi.
Hi, nice meeting you.
Okay. So you are from electrical background, right?
Yeah, instrumentation.
And postdoctorate.
So I completed my PhD recently and then joined here as a postdoc.
Okay, great. Yeah. So what precise area you are working as
So I'm working in an intersection of robotics, neuroscience and controls. So I come from a controls background.
Okay.
I got interested into neurosciences and robotics.
Okay.
So the work I'm right now doing is related to human learning.
Okay.
The learning that you see in humans, the way humans pick up skills, the way kids learn to draw, make fine motions, and so we are looking to it from a control standpoint.
Okay.
We are trying to understand how we can explain that from a controls perspective and make it useful to something in robotics.
So is your work somewhere related to cognitive science also?
You could say somewhat.
Okay.
Somewhat.
Little bit, huh?
Yeah. So drawing ideas from cognitive science, but your end goal then is to try to make robots learn like that, right?
Okay.
Robots that self-learn.
Making robots more human.
Yes.
That can learn from the environment. So he has made a lot of progress.
Okay. Great.
But even other people, everybody brings a different background. So we have Shubhankar, who is an intern here, who is actually an undergraduate student at University of Mumbai, but he's spending the semester here.
Okay.
Bharat is a PhD student.
Okay.
Hi, Bharat.
Okay.
Hi.
Okay.
Arpit, okay, yeah, I've not met you yet. So you just
background, Electrical.
So I'm
Mechanical.
yeah. So Arpit also just joined. So in fact, this is the first time I'm meeting him face to face. We exchange emails.
So how you are finding this entire research work?
So it's great. Like I'm working in this lab since 8 months.
Okay.
I joined PhD. I'm a direct PhD student.
Okay.
I joined-
Immediately after BTech.
Yes.
Okay.
So I joined the lab this January, and I'm working in this compliant robotic project with Professor has explained in detail.
Okay.
So my initial work is explained in the test bench, like how robots use compliance to do the unstable gripping task. So which Professor had explained very clearly.
Immediately after BTech, I presume that knowledge during graduation is very limited. So how are you finding, how are you coping with this, more learning here in PhD? This concept was not there earlier. BTech to direct PhD and, looks like a heavy degree. So are you in position to cope up with the new learning?
Yeah, totally agree. Like initially in BTech, we have a less exposure to like a research, as you said, mentioned. But then as we joined here, the exposure is quite exponential. So the growth also increases, and we get to learn from the peers a lot. So once here in lab, postdocs and the senior PhD guys help us a lot to get to a level which is required, and then we have professors are quite helpful to take us ahead.
Great. So all the best to all of you.
Thank you.
So we also have research staff like Sagar, did an MTech in mechanical engineering and works with us.
So he's completed,
Yeah, I have completed my master's from here only. And I have joined as a junior research fellow.
Yeah.
And I am currently working on this QR manipulator, which Professor Harish already explained.
Okay.
And currently, I am working on other different projects also.
Okay.
Combinedly with the compliance robot.
Okay.
And then next, Osaka, one of the research is going on in our lab.
Okay.
And I am working on multiple fields.
So in a lab like this, there is a lot of management that is also needed because we are all constantly getting new parts. We are ordering things. We have to make sure inventory is managed. If things go bad, they need to be replaced. Sagar is very good with handling all of that also. So he's sort of like a lab manager also. So he does both. He plays both roles.
Yeah.
So Rick, he's currently a BTech student here,
Okay.
but he spends a lot of time in the lab. He helps us in many of these projects. But he has diverse interests. He's also a footballer.
Okay.
He's also into mobile robotics. So he does many different things.
So which year you are present?
I'm in fourth year.
Fourth year. So you are working in this lab since?
I am working in this lab since I think from my second year. So
You are mechanical engineer.
yeah, mechanical.
Okay. So why you decided at the first place for robotics? Any idea?
Like my interest is in combining mechanical engineering along with artificial intelligence. That's
Great.
my main aim. So
Okay.
so to implement that, I thought that robotics will be a good platform to do that. And
Okay.
after doing that, I'm feeling great
Okay.
going on in the field of robotics.
Okay. So let me ask you a very ticklish question. Maybe you can answer.
Yeah.
Are you aware about the challenges of making robots artificially intelligent?
Yeah, like
If we do that, maybe you have seen some fiction movies.
yeah. So
There's a huge debate going on nowadays.
yeah, so there are many research that are still going on, but those are like the outcomes of those are really scary.
Yeah.
If you see that what those robots can do,
Yeah.
then the outcomes actually like how can I explain?
They cannot be good, right?
Yeah, they cannot be good and in the
So
long
is
term.
there in your mind when you're working all the time?
Yeah, that's
Okay.
always there.
Okay.
Yeah.
But if challenges are there, there are always solutions also.
Yeah.
Chalo, great. All the very best for your work. Okay.
So we have Shail here, who is also a PhD student. So
Okay.
he has a totally different background. He's a
Okay.
biomedical engineer
Biomedical.
who was actually working as a tech support in an operation theatre in the hospital before he joined us.
Good.
So he brings a totally different perspective, especially when we are doing things like that.
Okay, so for that.
Not just that, many other projects, but he really has seen the patient side, so he brings different perspectives.
So can you briefly tell, as a biotechnology, so you've done
No, not biotechnology, biomedical.
biomedical.
Yes.
So what is the opportunity for biomedical graduates in field of robotics, controls?
In robotics, there is indeed. So in the field of rehab robotics, the biomedical engineers can significantly contribute because they have the knowledge of biomechanics as well as biomedical engineers are trained to do some of the electronics since they're undergraduates in the starting of the year for second years. So they are good with the electronics also. And robotics requires significant amount of electronics and different mathematical backgrounds. And in biotechnology, you might not find lots of application of maths, but in biomedical engineering, you will have some concepts of maths also.
Okay.
So that helps us as a robotics
So
engineer.
can you suggest me some areas of application of robots and control system and all in biomedical?
Yeah, so the best application I can suggest is the Da Vinci robot.
Okay.
So that robot is the surgical robot. So recently, if you've seen around, so there are lots of posters are there which suggest that they are doing TKR, like total knee replacement surgery.
Yes, I've seen the hospitals robots are doing. Okay.
Yeah.
That one.
So there you need a proper biomedical engineer and robotist
Yes,
to
yes, yes.
do that.
Yes.
So yeah. Also there are some challenges to that. You cannot completely rely on the robots.
Yes, yes.
But when there is a smooth integration between the humans and robots,
Sure.
that's the sweet spot,
Yeah.
where we come in the great picture. Yeah.
That's wonderful.
Yeah.
Okay.
Yeah, so we have a large group, as you can see.
Yeah.
Few other people. So Varun He is again a research staff.
Okay.
He joined us from Maharashtra just recently.
Okay.
Yeah. Do you want to share about your background?
So I'm a mechanical engineer from Pune University and just graduated last year. And I'm working here as a project assistant, working on various research projects, including Osake. So we in this lab have designed and developed Osake robot, and after that, in order to implement some control, we are using various microcontrollers like STM32 microcontroller and SBRIO. So these microcontrollers, by implementing this kind of microcontroller, we could give we would gain whatever output we want.
Okay. So what is the application of what research you are doing?
So the application is, so put it in a simple word, like we are holding a cup. So if the cup is empty, then your hand is not that stiff. But once you pour some tea or anything in the cup, our hand becomes stiff. So in the same way, we are teaching robot to vary its stiffness in order to get a certain movement.
Okay.
So yeah, that's what we are doing.
Very well explained. Thanks. Great.
We have two other PhD students here. So Aishwarya, I think you met Aishwarya.
I met Aishwarya, yeah.
So
So Aishwarya, now I want you to tell us what PhD work. I think this is
So,
looks like you have spent a couple of years in PhD work now. Yeah.
so I'm working on something which is intermittent control,
Okay.
which will how it will help a human to balance himself.
Okay.
So basically, it is about we are considering there is a strategy which our brain uses for us to stand
Okay.
and balance on any unstable platform.
Okay.
So how does that strategy work? And we are exploring the dynamics behind it and how we are how the dynamics will actually work. That we are going to conduct some human subject experiments also later on.
Okay.
And then afterwards we will be using it. We might use it in some robotic applications or some other applications.
Great.
Also.
Great. So Aishwarya, after PhD, what are your plans?
After we
Job, teaching, entrepreneurship, what?
not
Maybe
yet decided.
No, not decided.
Yeah.
Do you know you are very close to decide now?
Yeah, I'm going to decide, but
Okay.
right now I want to
Good.
focus on.
Good. Thanks a lot.
Vignesh.
Yeah. Vignesh.
So he's our newest PhD student. So just joined
Yeah.
this semester actually.
Okay, great.
Yeah, I joined a couple of months ago, and I actually come from diverse background myself. So I did instrumentation in my undergraduate,
Okay.
and then I worked for a couple of years in the HVAC industry in a company called Johnson Controls, and then after that I worked as a JRF at IIT Bombay,
Okay.
like for close to a year, and then I came here and joined.
So you're instrumentation engineer, and now you're working in this particular domain.
Yeah, so I work in HVAC controls in the.
Okay. So Vignesh, as instrumentation engineer, now how do you think your expertise is going to be different from, let's say, mechanical engineer in robotics?
Yeah, of course.
So if some instrumentation engineer is listening to you,
Yeah.
and his question is very straight, what as instrumentation engineer I can do in robotics?
Okay, of course. Okay, the first thing is instrumentation engineers are really good with sensors.
Okay.
So sensors and actuators,
Actuators,
and
yeah.
designing the
Control.
dynamics of that, and choosing the right actuator, right sensor for a particular task, calibrating the sensors,
Yes.
calibrating the measurements taken by various other instruments also,
Yes.
and also to design the signal conditioning circuits involved. So all these aspects can be like well understood by an instrumentation engineer, and hence these are all, of course, very relevant in robotics. As sir was saying some time ago that robotics as such started with the goal of doing tasks in a precise manner.
Yes.
So precision is something which instrumentation engineers are like, they start with precision as the first concept in most instrumentation
That's
courses.
the bread and butter.
Yeah,
Yeah.
so precision and accuracy are two words which an instrumentation engineer would be able to explain better than someone who has done a PhD in English.
Okay. Perfectly said, Jignesh. All the very best. You are
Vignesh.
Vignesh, huh? You are Gujarati, if I am not wrong.
No.
Yeah.
I'm
This name looks like very. Okay, great. You are from Tamil.
No, I'm from Mumbai actually.
Okay.
So,
Okay. Great.
Thane to be precise again.
Okay.
So we have people from all over the country also here.
Yeah.
So just picking up on what Vignesh said, so one of the other projects that we have just started working on is a ISRO funded project to develop an actuator for a robotic application.
Okay.
For something like that, certainly instrumentation engineers.
is required.
So, that's
So
very
as of now we have people from the background of mechanical, biomedical, electrical, instrumentation.
Yes.
So truly interdisciplinary.
Yes. And we need every kind of expertise, and they all talk to each other. They have their own kind of family environment. There's a lot of fun also going on in the lab, but a lot of technical exchange also. But all of that is crucial to be successful in projects like this.
So I have two more things to ask you, Professor, related to this lab. Number one, I have seen a lot of things going on here. So what are the entrepreneurial opportunities for these students, if they think of getting into entrepreneurship a little later? So what opportunities?
No, excellent question. I think that is one area where there is huge opportunity in India at the moment.
Okay.
And of course there is a lot of focus on software startups where sometimes there is an app that helps you do something, or there is a system that helps you order, but I think the untapped opportunity is really hardware startups.
Okay.
Where you are now starting to make small devices,
yes,
whether it's for consumers,
yes,
consumer devices, or like I said, we are working on an actuator for ISRO, so the robotic application.
Okay.
So I think a lot of these, if you look in the country, are important at the moment.
Yeah.
There's a lot of opportunity for small hardware applications, whether it be like at component level, or device level, consumer level, or industry level. So I think that's a huge opportunity, and that's where we can really make an impact. So I encourage all students to consider that as a very important option when they are considering their choices. So just to give you an idea, one of our MTech students who just graduated this January is exploring a startup on his own.
Okay.
For instance, one of the things that we are collaboratively developing, I can just show you, is some hardware kits that help. This is again an educational application. So this is again little bit work in progress. Let me see if I can show something. Yeah, so it's a home build robotic kit.
Okay.
Which will help you learn robotics.
Okay.
So if you're a second year student, let's say somewhere else, you don't have the access to labs like this, but you still want to get a very solid education or exposure to hardware in robotics.
Yes.
There's one side which is line follower robots and drones that are very popular, but what is sometimes missing is really just going back to basics of knowing how to control each joint, how to control 2 links, 3 links. So I'm not able to show you the fully assembled version, but we are developing a kit here that will help people with such issues, where they can build at home and learn very solid fundamentals in robotics. So this is going back to what I was saying earlier. This is being explored in collaboration with one of our alumnus who is actually exploring a startup on his own.
Okay.
So I think there are a lot of opportunities.
So can we also think of creating some sort of kit for school children to learn what this particular robotics?
Yes, absolutely. Yes, absolutely. I think there are again a lot of interest in that area. I think there are few startups I already have heard about in that direction, and I think there's as I said, lot of opportunity. Specifically from the lab, I think our focus has been that we are learning things here, we are doing things here that perhaps some of the things nobody else in the world has done.
Okay.
So we want to capitalize on that when we are building something that is something unique that that can come out of our experience.
Okay.
The school children kit, it's very useful, but I think other people are perhaps doing
They
that
are working
better.
into that domain.
But some of the students may be interested in taking that up,
as a
after they graduate.
definitely opportunity.
But I agree that there is a lot of.
Now, my last question to you, Professor, is related to the lab itself. There's this understanding the students who aspire to learn in robotics. There's an understanding that there are different center of excellence in India, different IITs, old IITs. This is new IIT. So where do we rate this lab of robotics compared to other such labs which are existing in other institutes in India?
See, it's not easy to compare because
Yes.
I think each lab has a different flavor
Peculiarity,
and different focus area. I think there are some really good labs in the country, and a lot of them, I think the last 3-4 years, next 5 years is really a pivotal time for robotics.
Okay.
Because I think when I was a student or even 10 years ago, hardware was expensive. As a student, you would never think of buying hardware to learn something. जो क्लास के demonstration lab में दिख गया उतना ही. You never actually did anything. But now we are just reaching that stage where every engineering student expects to get some real hands-on experience, either real project, really building something, really building a robot on their own. So I think it's a very exciting time. A lot of labs are coming up, but all of these labs, or many of these labs, are in the cusp. I think in 3-4 years, 5 years, I think many of these labs will be among the best in the world. So
Okay.
we have the same aspiration. Many of the things
Yes.
that we are doing here, we feel in 2 years will be the best in the world.
So what is your next couple of years of vision for your lab?
There are a lot of open problems out there.
Okay.
I think as long as we have a good team, we are having fun, we are exploring something new that nobody else has done, good things will come out of it.
Okay.
So we do have some focus points, but the rest, comes out of pursuing something that you are excited about.
Great. So let me thank you, Professor Harish, now for this wonderful session with all your PhD students and all the facilities you have shown. I'm very sure this entire interaction and information will help a lot of students who aspire to be in the institutes like IIT Gandhinagar and work in the domains in which you are working.
Absolutely. Thanks a lot. It's been my pleasure. And I would say, all the young students out there should really look for opportunities where they can get involved in such things. Even if it's a summer internship, even if it's a small project, try to contact labs that you are excited about. See if there are opportunities. See if there are. So all the best to all of you.
Thank you.